Okay, guys, we are now on record. First thing, a little bit of revisor on PNC. Okay, I'm going to be asking you a simple idea, which is we understand the basics of circular arrangement, cyclic permutations. Okay, so I always start this revisor by asking you the simple idea that we all understand how to place n people in n positions, let's say chairs or whatever. We know this thing now this in linear fashion we can do this in n factorial ways, but when it is a circular disk, the problem that generally we have, I think this is going to be far more quicker. So the thing would be, if I have, let's say, n people, n factorial, this is linear permutations, no problem in that. Okay, everybody, like for example, if I say there are 4 positions available, the first person can take any one of the 4 positions, everything is allowed to him. The second, once he's taken his seat, 3, the next person can take the seat in 3 factorial ways, and then 2 factorial, and then basically 2 ways, 3 ways, 2 ways, and 1 way. Ultimately, if you see 4 into 3 into 2 into 1, that is the total number of ways in which you can arrange these people among themselves, right? And I'm saying total number of ways because the first person has 4 possibilities, this one also, this one also, this one also, this one, that's why 4 over there. Okay, third one similarly, this one, this one, this one, so 3, and so on and so forth. This is the basic that we know so much about. Now what is so much different about this linear permutation versus the cyclic permutation is that, suppose I have some locations 1, 2, 3, and 4. Okay, I have these locations with me, and I have again the same 4 persons. We have discussed so much in depth permutation, we have done so much in depth analysis of permutation combination, but I'm still coming back to cyclic permutation because I think this is important. Now please understand, 4 persons. Okay, the first person comes in, every chair is just one identical piece of position for him. For example, if the first person comes, there is one chair right across him. If suppose the first person comes and you make him sit at chair number 1, one chair to the right, one to the left. Okay, I could be wrong, matlab, but then you understand that my right is his left, so that is one of those things. Okay, so one to the left, one to the right, and one straight in there. This is one of the positions that he can choose. If I, let's say, if I ask him to sit at 4th position, again the same situation, one chair diametrically opposite, one towards the left, one towards the right, and basically none of the position, basically for the first person, if everything is vacant, everything is identical, and there is only one way for such permutations. Okay, this is important. When you have everything identical, there is only one way possible. Please keep this thing in mind, because the next idea that I'm going to be discussing, which we have already studied in our previous classes, but because I'm, let's say, reiterating certain things, this will help you grab that idea quickly. Okay, now what is it that I said? Identical. Keep this thing in your mind for the time being. Okay, now the first person comes in, takes a position. Let's say I'm the first person, I have taken the first position. Now the second person that comes in, the second person now have 3 positions. Okay, and 3 independent positions. These are not identical now. The next person, let's say the green guy, the yellow guy and the green guy. Ideally, so I should have made it in yellow, or I should have made it in, let's say, this thing. Okay. Anyways, now green guy, left hand side, 1 person already sitting. Right hand side, 3 vacant positions for the 4th position. Now, is this any similar for him if I try to make him sit in this position? No. Earlier, 1 person was to the left of him, but now 1 person is diametrically opposite, and then 1 to the left and 1 to the right is vacant. So obviously this 3 and 4 are not identical, they are distinct. That is basically the idea of permutation. Okay, this is the basic idea of permutation. Now please understand one more thing. Let's say once we have decided to make the 4 persons sit there. Okay, once we have made our decision that these are the 4 persons that are sitting over there. Now, if I start, let's say, rotating them, internal rotation, if I give them internal rotation, nothing really changes. Nothing really changes. I mean, try to think of this in this term that, if you're looking at a perspective, like if you are taking a perspective of these peoples, you will realize that just by changing the position, let's say the white guy goes to this position 2. So the green guy will go to 1. I mean, I'm saying clockwise permutation. Okay. Green guy will go to 1 and the blue guy will go to 3. And again, the same thing will repeat, right? So what I'm saying is that let me do that also, just in case. Okay. So I'm saying this guy comes to this position. Okay. This position. Now, obviously for clockwise rotation, the green will come to this position. Okay. And the orange will also, sorry, not the orange, the blue will also slide. So this is the blue will also slide. Okay, I'm just making it like that. And the other one is the orange one, right? So you realize white, green, blue. So white, green, blue, and the other one is the orange. Okay. So what we have done, what we have tried to do is we have done a clockwise, let's say, rotation. Nothing really changes. If you see toward my right hand side, or let's say towards the right hand side of the white one, you still have the green one. If you realize toward the right hand side, still the green one and blue one, right? The only problem is that when you flip the positions, okay, when you flip the positions, what does that mean? Flipping the position basically means, now please pay attention, this is important. Okay, what does this mean? It means clockwise versus anti-clockwise, clockwise versus anti-clockwise permutations are distinguishable. Now let's try to understand this thing little bit, and then probably we'll go to the next part. Okay, so far I'm pretty sure no problem, nothing like that. I'm erasing everything. Let me take you to a blank space that can help me draw, that can help me. Okay, so what is it that I said? I said that, with the human beings, the possibilities were limited. So the 4 possibilities, let's say I am starting to name them. Let's say Ravi, Suresh, um, Tarzan, and let's say Pinky. Any now, if you're trying, please understand what I'm trying to tell you, or pay attention. What I'm trying to tell you is that consider a arrow. Okay, consider a arrow. Okay, this is how my physics teacher used to teach in basically the in school standards, not school standard, in my coaching when I was taking school. Okay, this will help you understand the top down bottoms up view. Okay, now I am saying this is top down, so just put the arrow in your hand and try to understand that you are aiming the arrow from top to this table. Okay, now what does this cross represent? This cross will represent the tail of the arrow. You can see there are many, let's say, fragments of this tail. So this X will indicate the fragments of that tail. So this is a top down. And obviously when you, let's say, shoot an arrow from the top to the down position, ideally this head of the arrow will go inside the table. You will not be able to see it. I am pretty sure you're understanding what I'm saying. Okay, this is the top down view. What about a bottoms up view? A bottoms up view, I am trying to make the bottoms this thing. Okay. A little bit of kalakari, just for the sake of kalakari bazi. If I'm looking from bottom to up, okay, bottoms up, again, this is Ravi and this one will be Tarzan. Okay. But understand this thing. If I'm looking from downward, okay, you can also say, okay, but sir, if I, let's say if this is a glass table, nothing will change. But try to just visualize that. If you have a, I don't know how to show this thing in 2 dimension, but maybe if you could just, stretch your palms out, you will realize when you look it from the bottom view, the position of the Suresh and Pinky should change. Okay, and even if they're not changing, let's just make it even easier. Okay, if there is any problem with tops down, bottoms up, ideally though there would be a dot and a cross. But let's understand, even if that is difficult, let's understand one thing, that we have, like I have not I have, but this is what we generally do. This, let's just flip the orientation. If we flip the orientation, everything remains in along this axis of symmetry. So suppose this axis of symmetry is remain same and you just twist it. Okay, rotate it. You just rotate it once. The once you rotated it, this is Suresh and this is Pinky. Okay, if you just try to understand this, no, never in your life ever you are going to get confused with cyclic permutation. And why is it that we do n minus 1 factorial? And one of the non-distinguishable cases may we do n minus 1 upon 2, n minus 1 factorial by 2. Why is that we do? Now, understand this thing. Just now we have understood that if somebody comes in, suppose there are 4 persons comes in, the number of ways in which you can make the arrangement is 4 minus 1 factorial. Okay, so 4 minus 1 factorial is 3 factorial. Okay, yeah. Now, yeah, everything seems okay. Everything seems sorted. Yeah. Let us try and understand what I was saying. The moment I introduce the formulas, you can see now even my mind is also trying to look into the formula. So let's just forget about the formula for a while. Let's just forget about the formula. Just let's try and understand the situation right now. What I'm saying is that when we have these many permutations, first of all, so there could be many internal rotations. For example, again the same idea, 1, 2, 3 and 4, these are all positions, na? These are all position 1, 2, 3, 4 in that order, clockwise order. So Ravi is occupying 1, Suresh is occupying 2 and 3 and 4. So ideally the fact is that I can have 4 arrangements. Let's say if I have boxes 1, 2, 3 and 4. In these 4 boxes, Ravi, Suresh, Tarzan and Pinky is one of the orientation. Another orientation is when you just shift everybody to the right, okay, clockwise. So this becomes, ideally this will become Pinky, Ravi, Suresh, Tarzan. This is one of the orientations. And you realize that there will be many orientations. What I'm trying to say just now, because we discussed this thing, due to the symmetry, or you can say symmetry or the perspective of the situation, all these internal permutations are all but one. Okay, the only time the permutations are different when you actually consider this one and this one. Okay, so could there be any other permutation that you can do? Definitely you can now flip this position. Okay, so the moment I say for 4 positions, it becomes a little difficult to even visualize it. With 3 it is very easy. With 3 it is easy, because if this is okay, I'm just removing it, okay, because I don't have a lot of space. So what I'm saying is that, see, pay attention. What I'm saying is that if I have 3 positions, it becomes easier for me to explain, because 1 person is fixed and only 2 person get reversed. But the moment I introduce, let's say 4 persons, now if I just fix this thing, then there is one orientation. Again, if I fix this thing, let's say, then I have 2 orientations. So there ideally should be many orientations depending on that. And in a situation like that, the formula n minus 1 factorial makes a lot of sense, because generally We can list the permutations also. I mean, I don't want to do that honestly, because that is going to be a lot of lost effort, but we can do that, right? If you want, we can do that. I mean, just now we did it now. So 1, 2, 3, and 4, we did one of the permutation, which is, this Ravi Suresh. So RS TP, right? Ravi Suresh and TNP. So RSTP. So then you can very well understand that 1, 2, 3, and 4. There could be many possibilities. One of the possibilities is RSTP. It could be, let's say, RSTP, and then again I can go one more step. So I can make it like this: RST and P. Sorry. Yeah, no, it's okay. RSTP. And then let's say one more orientation would be R, S, T, and P. Okay. Is this it? I think if I just make all this clockwise permutation, these are the ones that I will be getting. Okay. But all of these permutations are nothing but one permutation, because everybody is just next to each other. So RK, if you just look at the vicinity, the people are not changing. The people in the vicinity of R and R are not changing. So if you take R, ST, then again R, ST, then again R, ST, the people are not changing. Obviously, I'm jotting this down as a table, so it may create some issues, but it is not changing. R, ST, and so on and so forth, right? The point is that there could be many internal rotation, there could be many internal permutations. All of these are just one. But the only time it will be different if I have something like this. If I have something like this, let's say T, or yeah, okay, let's do this thing, and P and S. Okay, so 1, 2, 3, and 4. The same numbering are there. So 1, 2, 3, 4. Do I have anything like TPRS? Yes, I have TPRS also. And if I just, let's say, change the position now, again make it R, and this I am making T. Do I have a RPTS? Do I have a RPTS? Oh no, I don't have a RPTS. So the point that I'm trying to make is that with let's say clockwise rotations, one arrangement I'm getting unique that I'm not getting with the internal rotations. That is RP, then T, and then S. Do I have RPTS? No, because again P is towards the left hand side. So this is the problem, and this is what we say as a different permutation. And actually, if you jot down, you might get the 6 possibilities. In how many ways? 6 ways. 3 minus 1 factorial, right? I am not doing that. You can do that as a part of your exercise, and you should do that if, in fact, if you want to learn something. These are all logical ideas. If you want to learn something, you should do it. Okay. Now, if we have understood, I can do that. We probably will. I'll do that also towards the end of it. But right now, just let's pay attention to the fact that just by rotating them internally, like I'm just saying that one person changes the chair in clockwise direction, one particular orientation I'm not getting. There could be 6 such possibilities, because we just now changed this possibility. We could also change the, this orientation. So if I just change the orientation, probably will arrive at 6 unique uh, positions for this RSTP thing. That is fine. How many ways for 4 people? It is ideally, though, we would have used 4 factorial, but now it is not 4 factorial. It is 4 minus 1, that is 3 factorial. That is only 6 ways. Earlier, in a linear, let's say in a linear arrangement, suppose I had 4 positions, it would have been 24. But right now it is only 6. Which are those unique 6 positions? I'm not doing it. You can do that as a part of your homework. But the interesting thing is, this is the most important thing. Now pay attention. Okay, this is very important. Please pay attention. The most important thing, the most crucial thing would be understanding the fact that all of these are human beings. Okay, I said Ramesh, Pinky, Tarzan, and Suresh. Okay. So obviously they are not identical. Not identical. Okay. They are not identical. Chalo, I'll take you back to what I was saying. I'll make the permutation thing simple. For me, I think it would become easier for me to explain with three positions. Okay. Ramesh, Suresh, and Tarzan. Okay. Now understand. Now we are going into the territory of cyclic permutation of non-distinguishable this thing. Non-distinguishable clockwise, anti-clockwise orientations. I'm saying these are all human beings, so they're not identical. Okay. So the position is that this is one of the let's say one of the arrangement. The other arrangement is going to be very simple. It is going to be okay. Basically, just flipping the or let's say changing the order or orientation or position of RS, R and T. The the is there any possibility of changing this to? I don't think so, because even if you just change this thing, it is as good as a rotation only. Like you're saying that R is taking the position of S, then obviously S will go to some other position T. I can make an arrangement of that also. T will go into the position of R and so on and so forth. So there's no point changing them. The ones who are diametrically opposite, it makes all the more sense, because the flipping becomes very easy. Remember, we had a axis of rotation, so we are rotating it, flipping it, right? Now this is one way to represent three people in a circular table. This is another way. Let's say first way, second way. Okay. There is no other way actually. There is no other way to say that is different. I can do that. I am pretty sure you have understood what I am trying to say so deliberately, so painfully, what I'm trying to say, that if I just start, rotating them internally, there will be some other permutations, but all of these permutation is nothing but RST only. If I, however, if I flip the position of T and S, the permutations that I will get R to T, T to S, and S to P. There will be again some permutations. These permutations may seem unique because of the, let's say, relative positioning. But if you pay attention to the perspective of the people that are sitting in that position, for example, if you look at T in second position, T के right hand side में you are getting R, left hand side में you are getting S. Okay. If you move T to this position, still left hand side and right hand side में it will be R and S only. So there is no point. Uh, there is no point emphasizing again and again that these are different. These are not different. So definitely these are two different positions. However, these two are the same, or these many permutations will be the same. Now the peculiar case. The peculiar case of, let's say a garland, okay, with a flower. Now, just to make things a little visual, I am giving them distinctive colors. The one problem that I had, let's say a different one. Okay. So this is a necklace, and let's say these are the stones. Okay. Now please understand, if I have the same Just a second. Let me just quickly draw this thing. Okay. And the last one is this one. All right. Although I should give the boundary lines just to, just to make things clear. Okay. Now, what about the orientation? First orientation, second orientation. If you realize, what we have done is a similar situation. We had three we had three items. I'm not using the word identical. Please pay attention to that. So let's say blue and green and red. And now we have blue and green and red. The only difference between the two orientations is that the other one is flipped. Okay, the other one is flipped. Now what difference does it make? One could have very easily said, but sir, it's the same thing as the one that we were doing with Ramesh, Suresh, Tarzan and Pinky. We could have just say 3 minus 1 factorial, that is two ways. And indeed there are two ways. Now this is one way, and this is the second way, right? Is there any other way? First way, second way? I mean, you can say, sir, I mean, you can strike the blue outside, but even with blue in the middle, there are two possibilities. Okay, so first of all, let's not overcomplicate the situation. Let's first of all understand what I'm trying to say. What I'm trying to say, with blue in the middle and these two people at the extreme ends, also is giving me two different set of permutations. But then I'm still saying that both of them are same. When I say both of them are same, in the case of beads, flowers or stones or whatever, I mean, I'm dividing this by 2. So this is 3 minus 1, that is 2 factorial, divide by 2. That gives me 1. So that means eventually what I'm trying to say is that this thing and this thing are not different. They're in fact both the same. But how is that so? You know that, towards the left hand side there is red stone, right hand side there is green stone, and over here that is left hand side green and red. So what is the problem? Like, this is like that, math is broken over here. Is math really broken? And the answer to that is no. Math is not broken. A little bit of understanding is required, because a lot of these words, distinguishable, non-distinguishable, this and that and whatnot, math is intact. What math says is that, remember, we use the word distinguishable. Okay. And when I say distinguishable, in the circular table, which is distinguishable? 1, 2, 3. The positions are distinguishable? No. Ram is very much distinguishable than Suresh, and Suresh is very much distinguishable than Tarzan. So when you swap Suresh and Tarzan to the positions, you get a new permutation. However, these are all but identical. Okay, these are all but identical beads. At this point, somebody says, hold on, sir. What if I have 3 different beads? Yeah, that's a different case. We'll not, let's not get ahead of ourselves. What I am saying is that the concept, the understanding, the theory says that typically in a garland, you will have the flower of same time. Like it is not very, I would say it's not very clean for you. Let's say you are doing a worship of some deity or whatever, yeah, some god. or goddess, you will not put different flowers, na? You will put only one flower. So again, logical, right? So in a necklace also, you will see if I have three different type of beads. Suppose I have a necklace like this, and I have one bead like this, another bead like this, okay, and one more bead like this. Now when I change the orientation, let's say, you know, your girlfriend, you gifted your girlfriend a bead collection, and she decided that no, I'm not wearing it this way, I'm wearing it this way, okay. But ultimately, friends, what I'm trying to tell you is that these are in fact beads. These are in fact beads. So what is this blue and red and blue or yellow? What is this? These are your placeholders. Remember, first, second, third. Similarly, Ramesh, Suresh, and Tarzan, the number of chairs. The number of chairs themselves do not have any symmetry, no perspective, nothing of that sort. It's only the Ramesh, Suresh, and Tarzan, they are distinguishable. And that's why when they swap their position, we say it's a new permutation. However, because these are identical beads, okay, they're identical beads. Why identical? Maybe you can say the shapes are identical. They're all circular in shape, of same size. Just by having different color does not give it a different property. Also, one other thing how I used to remember this in my school days is that, you know, inanimate object, and they don't have a perspective of their own. Basically, you will have a perspective. So when you have a perspective, it doesn't really matter whether you're wearing the bracelet, let's say in this orientation or in this orientation. Both the orientation are same for you. Like you can wear any one of the orientation, and that is why I will again say that is why the difference between clockwise and anti-clockwise, the difference between clockwise and anti-clockwise arrangement or orientations are wide. So there is no clockwise anti-clockwise, right? Basically, with Ramesh, Suresh, Tarzan, if I, let's say, go in the clockwise direction, I will have multiple orientations. But let's say Ramesh, Suresh, Tarzan, you can very well see the clockwise is very different from anti-clockwise. In both the orientations, one will give you Ramesh, Suresh, Tarzan, Ramesh, Suresh, Tarzan, and if you go anti-clockwise, also RTS, RTS, RTS. Over here, the clockwise and the anti-clockwise will have a difference. With the beads, that difference does not exist because the beads are identical. Okay, I think I have spoken a lot about this.
A lot.
Yeah. But then this was very important. This
Yeah.
was very important for a simple reason. The only position that you are going to get confused is whether it is identical versus distinct, distinguishable versus non-distinguishable.
Yeah.
And you will realize the entire permutation combination when they say difficult. What is so difficult about permutation combination? The only thing that is difficult is, you know, the idea whether it is distinguishable or not.
Hmm.
I think we have. I think I have the. Yeah.
I was just listening to you, and you so like it's very at times it get confused. That's
It is confusing, but now when you go back to the Unacademy PDFs,
mm.
everything
Mm.
will make sense crystal clear. Okay.
Yeah.
I'll take a 2 minutes break because my vocal cord is literally
Yeah. That is
paining.
why I've been planning my eyes on the screen, and actually I'll have to
Yeah.
go to the record. To be honest, I'll have to go to the recording again to make sure I understood the right.
No need for recording revisits. You can
Mm.
go. Obviously, the recording
Yeah.
is for that purpose only. But the I would say your time will be very much saved if you just go
Yeah.
to
Sure.
the PDF of the
Mm.
whatever, you know,
Mm.
books that we are following, and now everything will make sense. Okay, I
Mm.
will now take you to the agenda for today. The agenda would be, you know, going into the in-depth theory of grouping distribution. Before that, we'll revise partitioning method a little bit. I'll ask you a simple question. Okay, and the question will be, question is, get ready for the question, guys. The question is, In how many ways can you arrange?
Hmm. Hmm.
In how many ways can you distribute?
Hmm.
Let's say 7
Hmm.
identical
Hmm.
um, balls to 5 students. And
Hmm.
no need to say that students are obviously distinct in this case. Just a quick revisor because we did this yesterday.
It's a 12 factorial by.
13 factorial
Sorry,
by
sorry, 12 yeah, that's it.
13 factorial by 7 factorial into
5 factorial.
5 factorial.
So 12 factorial by 7 factorial, 5 factorial, 7 plus 5, 12.
I don't know. I'm getting multiple answers now. What is the
12,
answer?
12 factorial by 7 factorial into 5
How are you
factorial.
getting the 7 factorial, 12 factorial word? What are you doing?
I mean, sum of 7 plus 5.
Yes.
That is exactly what you don't have to do. That is exactly what you like have to become careful of. Remember what I said about partitioning balls and sticks.
Okay, four students, 4 students.
Balls and sticks. Remember
Yeah,
balls and sticks. How
four
do you make
students.
partitions?
4 students, not 5
4
students.
part.
Only four part, 4
One
part.
ball, two ball, three,
3 ball, 4
four,
ball.
7 balls, right? How
Yeah,
do you so one
4
partition
yeah,
to
sure.
another partition, another partition. So please understand it like this. Your this method is also called the method of balls and sticks is a little silly. So you can call it stars and whatever sticks, right? So yeah, so 7 balls and 3 sticks. Sorry, 4 sticks because we need 5 students. No, sorry, not 3, 4 and 4 sticks, right? So that is 11 factorial by 7 of one type and 4
And
of other type.
okay, yeah,
Now, this basically tells you that you have understood the theory, but not entirely.
yeah,
And do you understand? This is why practice is important. Okay, just by learning the theory is not sufficient ever. You have to do practice. As less like 2, 3 questions also. That's okay. 1, 2 question, 3 question, that is okay. And just in case somebody willing for a formula, very enthusiastic with the formula, n plus r minus 1 c r minus 1 is the formula. There are so many there are many students who used to love these things in my school, my coaching. And n plus r minus 1 c r minus 1, all that. They mug up the formula as if they think that there will be one question that they can put the formulas into. No, at least competitive exams they will never ask you question that is directly formula oriented, because there will be one odd muggu who will be mugging up all the formulas, and you will see them in cat centers also, somebody with their Arun Sharma books or some Verma book and revising the formulas.
yeah, right. I've seen many,
Yeah.
and I thought, okay, these guys are gonna be IIM.
Yeah, anyway.
Every time I used to go for the exam, I wear hand like all I have is a hall ticket and a pen, and people stares at me. Why is this guy serious?
Yeah.
I just go with a casual 3/4 or so. I used to be a 3/4 for the exam every time.
Yeah. Like I can totally subscribe to somebody who has like 5, 6 books with them if
Yeah,
they're going for a university exam. That is how university exams are designed. But if you are doing that thing for an aptitude exam, then you have missed the point by miles. Because an
yeah,
aptitude exam is not at all dependent on your understanding. Like your memory, sorry. Chalo, let's go to the. What is it that we were doing yesterday? We were doing the distribution, no?
Yes, sir.
yeah.
Arranging, dearranging, distribution,
Yes, yes,
grouping.
yes, 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 yes. Today I am supposed to tell you the question types. We have understood grouping, identical chocolate distributed to distinct students. So also, if you want to remember something, remember this, that the right now what we did partitioning is identical to distinct. distribution of identical items to distinct, let's say, objects. Okay, this is distributing. You can call it number one. This is one of the ways, distributing identical to distinct. There will be something, distinct to distinct, identical to identical, and so on and so forth, right? So now let's focus on the question types.
One minute, I'll be back.
Yeah, I'll also take a 2 minutes break because I've been talking a lot. I'll just write the question types. I think he is a little overexcited today.
Yes.
How many numbers less than 10,000 adds up to 15? I'll tell you when to take a screenshot. So right now, don't worry. I'll tell you take a screenshot and all that. Yeah. So these are the question types that can be asked. I mean, these are like, I'm not giving you an exhaustive list. Could be the ones that can be tested. Um, of which the ones that I genuinely think is a little challenging, uh, this is going to be a little challenging. Okay, this is going to be a little challenging because the fact that this is an inequality, and we are aware of the fact with equality. So because this is an inequality, this will become a little challenging. So we will have to make do with this, right? I might as well drop this question also because sometimes these type of questions become a lot difficult. So just
Whenever I get to see this kind of questions, sure. Next question.
See, the point is that even if I teach you, and let's say we get an answer, the problem is that I don't think that you will have enough time and mental capacity to solve this type of question in a exam
Never,
condition.
never. If there is a data question, then I would most probably like
And
choose a
mostly you
random
will
number
get these
and
type of question in theta only.
yeah. And if there is data question, like for the all those difficult law questions are not okay.
Hmm, hmm, hmm,
Even if we are not able to solve, if that is data question, just give 0, 1 or 2 values. Because most probably the values would be under 3 or 4 for these law questions are not.
hmm,
I used to have that kind of thing. And for the LRDI thing, even if you are not able to solve an entire set, if they ask how many numbers can you determine, if there is no CBD, then there has to be a number, right?
hmm,
So the data question just go random number 4 or number 2. Don't go for this odd number. Go
hmm,
for this even number. Only even number.
hmm, hmm,
Because if there is a CBD, then it has to be with two different, right?
hmm,
So if the total contestants are 8 to 5, 5, 6, A, B, C, D, like 6 people, then 2, 4, or 6 would be the answer.
hmm.
Because if there is a CBD, then it has to do with two people. That's a logic.
Acha, guys, tell me one thing. Do you want probability in the next class, or should we do a little bit of set theory and functions? Because
We'll do set theory
see,
and functions.
probability is not important for CAT, but it could be like it can give you many perspectives. And see, what I'm saying is you don't have to solve any questions in these chapters. You don't have to solve. Just focus on what the classes are doing.
Yeah, set theory and functions. We have to go through that.
Or maybe we'll do set theory and function in one class on Sunday at afternoon.
Yeah, afternoon will be fine. Like 4:35 to 8.
Today is Wednesday, na? Hold on.
No,
Friday.
no, Friday.
Oh shit.
Friday.
Shit.
Yeah.
I have I've lost track of time, date and everything. Anyways, then Sunday wouldn't be possible. I'll be taking a break. I'm going out for a movie. The girl is gonna kill me.
Sunday 10:30 will be fine, right?
I can't. I'll be back a little late in the night.
Tomorrow?
I will let you know. Tomorrow I'll let you know. But most probably no. So that's why we did many classes. Now this Monday we didn't do a class, but I think we did
We've been
classes.
doing one Wednesday, Thursday, Friday.
Wednesday, Thursday, Friday. Tuesday also we did one class, I guess.
No, no, no.
No, I think in the afternoon we did.
No, remember that. I'm
Okay,
lost.
anyways, leave it. Anyways,
How how weightage should we give to functions? Okay.
देखो, the thing with function again, black and white. You can solve it, you can't solve it. Simple.
Yeah,
I
that's
think this is what I know and this is what has helped me. So yeah, black, white, simple. Permutation combination, gray area is there. Probability, gray area is there. Set theory, gray area is there. Probability will be there in ZAT. Probability questions are pretty much there in the ZAT. Let me just see how long the probability is. So we will start with probability, the events, the simple empirical probability, the class 10 standard probability. Then we have the De Morgan's law. This is where class 10th is over, complement of an event. And then we enter into 12th standard, that is exhaustive events, mutually exclusive events, independent events, conditional probability, binomial probability. And the last part would be Bayes theorem. I think it will take one class, two class max. Let's finish probability also. Because again, the notes that I'm giving you, that is it. You don't need to do anything beyond the notes. And the beauty of the this thing would be that once my classes are done, you will be able to understand everything from any particular handout module, classware material, Arun Sharma, Verma, whatever you want to pick, you will be able to understand. Right now the problem is also that when you pick a book, you're not able to understand many things. For example, how is it that you will join conditional probability to Bayes theorem? Many people will be very much Not happy with binomial, this thing, Bernoulli's trial, binomial probability. But these are the things that you will be using in your IIMs. I mean, in your MBA rather, or wherever you are. Hopefully, fingers crossed, everybody should be in IIM. But I'm saying that if you have a good professor, a statistics professor, they will take the reign. They will teach you many, many, many things, none of which you will be using in the real world. But the point is that if you are in good hands, at least you will enjoy the classes. You'll learn something. Maybe you will not use it ever, but this will give you some neural plasticity. Guys, have you taken the screenshot?
Yes, sir.
Okay. Okay, let's start. Okay, we'll start off with the first question itself. The first question says that how many numbers less than 10,000 adds up to 15? So if you have understood the question, okay. Now I'm erasing the other parts. I could have erased it in the over there also. So guys, do you have any idea when Pushpa is getting released?
50 days.
December.
December 15th.
Yeah.
I mean, in the month of December.
Okay.
We'll break every record. The highest.
So Varun is very excited.
Yeah, I'm very excited. I'm very excited about the business that film is gonna do. More of like this. I want to see how that film performs in the box office. Like,
Yeah.
will it cross the first day FD of RRR? And all?
Yeah. RRR was very good movie.
Yeah. The thing is that that film is an Allu Arjun film rather than a Rajamouli film, so that's why guy is single-handedly shouldering the whole movie. So the film is blockbuster, then he would be the biggest star after that, even crossing Prabhas.
Acha, guys, too much Prabhas and Mauli and all that. Let's focus on this. I'll give you some time. First of all, tell me what are you going to do about this question? It says how many numbers less than 10,000 add up to 15. How do you solve this?
Add up to 15.
Yeah, how many number less than 10,000? Acha, first of all, tell me, how do you picture this question? How do you picture this question? Is this question any different from the 15 identical chocolates and 4 students? Think of it.
So this add up to 15 means
Numbers below 14 will.
No.
yeah, see,
I
this
mean,
add
integers.
up to 15. The numbers less than 10,000 add up to 15.
Okay, if I say numbers less than 10,000, that means up till what?
Number. Up till 9999.
How many digits? How many digits? 9999? Four digits or 5 digits? Think about it.
4 digits only.
So if I, let's say, unit digit as A, tens digit as B, 100 digit as C, let's say, and so on and so forth, right? So it could be A, B, and C, D. Just read the question. How many numbers less than 10,000 adds up to 15? Adds up to 15. What does that mean? They're talking about the digital sum.
Oh yeah, some of the digits.
They are talking about the digital sum. They're not talking about all the numbers that add up to 10,000 or anything. They are saying numbers should be less than 10,000. That means the individual numbers. Okay. Now I will just shut up. I'll come back in 2 minutes. I'll take a break. Maybe in 3 minutes. I'll come back in 3 minutes. Think about this. It is not any different. I have given you every clue. A plus B plus C plus D is equals to 15. Because it has to add up to 15. But there is a catch. I'll not tell you the catch. Okay. But a plus b plus c plus d is 15 equals to 15. Okay, I'll be back in 2 minutes. Maybe 3-4 minutes. Yeah, I'll just be back. Okay, I'm back.
Yeah.
So do we have any answer?
Adds up to 15. See, if ABCD is for the number A plus B plus C plus D should be 15, right?
Yeah.
That's the logic, right?
Yeah.
So, if a number has to be 15, then it has to be like, oh, there are too many numbers.
Sir, I mean,
Hmm.
in the position of A, uh, we need to only get
Sorry, I
No,
was
no,
just
1 minute, 1 minute.
sneezing. Yeah. See, I'm not answering. So let's say w plus x plus y plus z. I'm not using ABCD. You can use ABCD. Doesn't matter. Is equals to 15. These are your digits, right? Unit tens, hundreds, thousand, 10,000, right? Please understand all of them are digits, right? So there should be some condition on w, x, y, and z. All of them has to be less than or equals to 9. Now, any number that I can put uh, in the position of w could either be 0, 1, 2, 3, 4, whatever, but till 9, because anything beyond that is not allowed. Acha, one question: is 0 allowed in w position? Yes, because we are looking at number less than 10,000. So one digit number also, two digit number also, three digit number also, and so on and so forth. How do we do this thing? Bolo, think. Suddenly I'm
We'll have to think like nine. If nine comes in the first place, then
suddenly I'm
how?
feeling a little cold. Yeah. Please continue.
Yeah, if nine comes in on W,
Hmm.
then how many digit would sums up 15? Likewise, 8, 7, 6, 5. We have to put on W, right?
Actually, see, there are going to be many violations in this. This is actually a difficult question, right? So I don't know how you will be able to understand this. Let's see. Acha, just tell me one thing. Had the condition that w, x, y, and z not been there, the condition that w, x, y, and z less than equals to 9 or 8 or 7, whatever, less than or equal to 9, the condition had not been there. In that case, the answer would be, it would have been very simple, na? 18C3.
So once more.
18C3 is like, again, na? 15 dots,
Hmm.
3 sticks.
Yeah, 18 C 3. 18 by 15 factorial by 3 factorial.
Yeah, I'm just using this thing as simply as 15C3. Okay. I'm saying, had the conditions not been there.
Wait. Let me tell you something, please. Hello, you are saying
Hmm.
W plus X plus Y plus Z is like, uh, yeah, W can be like 15 dots is like 15 students. W is 4 students. After division comes X is 5 students. Likewise, right?
Hmm.
Okay.
Basically, understand W can be 15 also, and others
Yeah.
could be 000.
Hmm.
But W cannot be 15 because it's a digit. It has
Yeah.
to be less than 9. It could be 0, but till 9.
Hmm.
More than 9 not allowed, right? So basically, what do we understand? That 15C3 has those conditions, or only those situations also, which are actually violating the condition that, this condition. So basically, we need to just subtract the violation. So if you have to understand this in one sense, uh, it will be 15C3 minus the violations. How do we calculate the violations? Think about this.
Violations.
Yes. Actually, I've become a little rusty with these concepts, so I am also not quite. I'm also thinking, okay, but the answer will be 15C3 minus some. Hold on, I'm extremely sorry. This is 18C3. Okay, why is it that none of you guys pointed this out? Why would be it be 15C3? It is 18C3. Yeah, it is 18C3. 18C3 minus the violation. How do I calculate the violations?
Any single digit number.
No, no. Think about it. Okay. Acha, let's do one thing. Let's substitute. Remember, W plus X plus Y plus Z is equals to 15, and we know that the number has to be less than equals to 9. So the violation would be, let's just substitute 10 over there. Okay.
Yeah.
If I substitute W as 10, it is a violation. Is it or is it not?
Yeah, it is a violation because it has to be. Oh, it's a violation. But it's not a single digit number, by the way. It's a two digit number.
Yes, yes. If I substitute the value of W as 10, then X plus Y plus Z is equals to how much?
5.
Right?
Yeah.
Subtract. You'll get 10. Arey, what is this? I'm sorry for this. I guess the OneNote is having some issues. Please ignore that, right? The moment I substitute, okay, guys, can you hear me? Hello?
Yes, sir.
Okay. Just pay attention to what I am saying. I said the value has. I'm extremely sorry. I am suddenly, because of this thing, I'm making many errors. Okay, just ignore that. This is going to be 13. This is. Just give me 1 second. Yeah, I'm just gonna
Okay.
get this thing sorted. Yeah, this is 18. 18 minus 10.
Then 8.
Because the value will be 8.
8.
Okay. So this is 8.
Hmm.
This is 8. Now try to understand what I'm saying, right? We said that if there were no conditions as such that, because these are individual digits, the value of these individual digits has to be less than equal to 9. So if this condition was not there, the value would have been 18C3. Okay. But since we have a condition, there are multiple violations because, hold on, I think this will be 15 itself. Yeah, this is correct. Yeah, I messed it up. This is 15. This is 15. Sorry, I'll do it again. Okay, just give me 1 second. I'll do it again. Just give me 1 second. I think, uh, the technical snags basically just put me off sometime. I'll do it again. Just bear with me for 1 second. All right. W plus X plus Y plus Z is 15. 18C3 happens because of partitioning. Okay, so that everything is perfect. The point is that I want to violate the condition now for calculating the number of violations. So what I am saying is that the moment I substitute W as 10, I am violating my condition. So what I am left is that this X, I will just, take the 10 to the RHS and this becomes minus 10 and X plus Y plus Z is equals to 5. I'll write it like this. X plus Y plus Z is equals to 5. Now, this is your new condition for the violations. Okay, this is the new equation for the violation. And how many ways of arranging this? This is as good as 7C2. Hello? Because 3 variables, 5 numbers. So there will be 5 stars and 2 sticks. So the partition will be like that. 1, 2, 3, 4, and 5, and 2 sticks, right? So total 1, 2, 3, 4, 5, 6, 7. So 7 for that and for 2 for the stick. So 7C2. Now understand 7C2. What is this 7C2? Now understand this. Think about this. What is this? X plus Y plus Z. Just tell me what is X plus Y plus Z. Varun, can you hear me?
X plus Y set is 5.
No. The value of X plus Y plus Z. What is the value of X plus Y plus Z? All the possible values that it can take.
Okay.
All the possible values. It can take a 5, 4, and so on and so forth, right? So I am saying just by substituting this particular entity as 10, I'm actually accounting for all the violations. Varun, I am repeating myself just in case you have not understood it. Okay, because I think I lost you there. The thing is that first of all we calculated 18C3 and the violations. Let's do it fresh. We had how many numbers? We had how many digits? 4 digits. W plus X plus Y plus Z, that is equals to 15. But there is a violation that W, X, Y, and Z has to be less than equals to 9 because all of them are individual digits. Now, had the condition not been there, I would have gotten all the number of ways as 18C3, right? Now, what is 18C3? Please understand, I'm recapping. You guys already know what this is. Now, I'm assuming without the violation, this could be 15, 0, 0, 0, and this is a possible. But I know that W is a digit, and the digit cannot be more than 9. So it has to be less than equal to 9. So I will have certain violations. Now, I am accounting for those violations. How do I account for those violations? First of all, I will just violate a condition. So X plus Y plus Z is equals to 15. I'll substitute W as 10 because one digit, if I just increase, it will cause a violation and everything else remains the same. This should be equals to 15. In other words, X plus Y plus Z should be equals to 5. Now, this equation will account for all the violations of the digits. Why? Because if I have one digit as 10, the others will anyways violate. Na? Think about this logically. If any one of the digit is violating, any other possibility will also violate. Will it or will it not? Baba, we cannot make a, let's say, 4-digit number, the 999 less than 10,000. We cannot make it by a digit like 15, na? Or 10 or 11, anything like that. So the moment I substitute the digit A, so it has to be a single digit. It cannot be more than 9. So the moment I violate it, any other combination or any other permutation of X, Y, and Z will be the, subsequent violations. Now, how many violations? Now use the formula n plus r minus 1. See, r minus 1. This is the formula for, the partitioning that we have studied. And this thing, how many violation? Violation will be 7C2.
7 factorial by 5 factorial by 2 factorial.
Yeah, 7 whatever factorial notation will also work. 7 factorial by 7. Sorry, not 7 factorial. The this thing would be Yeah, 7 by 5 into 2. So this is going to be 7 factorial by 5 factorial into 2 factorial. This is what it will be. But I'm saying this, don't get confused between the, the 5 balls and 2 partitions. Okay, the 5 balls and 2 partitions. This thing also give you 7 factorial by 5 factorial into 2 factorial. So does 7c2 gives you, right? Now we have calculated all the violations. So the final answer would be how much? Tell me quickly, guys.
So before that, one more doubt. Like,
Hmm.
what if W is 11, the same 11, then X plus Y plus Z would be 4, right? Then that then
See,
adds up.
okay, hold on. If W is the moment I so one number more than 10, that is enough for me to get every other permutations. If it is 11, if it is 12, if it is 13, these are just different cases, different permutations.
Mhm.
The moment I'm saying I'm taking the least number that violates and everything else is a violation. Did you understand the logic that I am saying? So
Okay.
you just,
Hmm,
otherwise you just sit and put the values, you will not get
okay,
anywhere.
okay. So putting the least value and getting the other violations as well. Okay,
Yes. I
that's
have one more question. Don't worry, I'll have enough one more question. So we are not going anywhere. We are here. So the first question type is over. How many numbers less than 10,000? And whatever the number, 18, C3, 7, C2, do your calculation. That is the answer, right? So let's go to the next question. The next question, if you remember, it was 4 dice are thrown. What is the probability to get the sum of 15? I'm not solving it. I'm not solving it. You have the screenshot with you, na? Guys,
Yes, sir.
I think Varun does not have it. Varun Gopal.
I have.
Okay. If 4 dice are thrown, these are 4 dice. Okay. Now, the point that if 4 dice are thrown, what is the probability to get the sum of 15? Probability to get the sum of 15. That means all the 4 dice should add up to 15. Okay. That is the to get the probability. However, probability and all that, forget about that for a while. Do we have any conditions here or not? Oh, yes, we have conditions. The conditions are A, B, C, and D. They have to be greater than or equal to 1. It cannot be 0. Remember, the die has 6 faces, and each face you have some number written on it. 1, 2, 3, 4, 5, 6, right? Also, simultaneously A, B, C, and D. So there is a upper limit. A, B, C, and D. The lower limit will be less than equals to 6. These are the conditions. So now, initially we had just one condition. We were just looking at the, let's say, the upper limit, right? Now we have two conditions that we need to take care of. How do we do that?
ABCD has to be less than 6. What if A is equal to 7? B
First,
plus C.
first of all, I'm not solving this. We'll reach at this question. Okay, this is the second question type. Okay, so this is the second question type. I'm not solving it yet because you might get confused. I have to teach you the violation method first. Okay, because you guys will, you will get left, right, and center. You will not get anything. So second is like this. So there are two conditions. We just now solved one question with one condition. There are two conditions now. Okay. Now, the third question type. The third question type is, if you remember, it talked about an inequality, that is A plus B plus C plus D is less than or equal to 15. And we are supposed to find out the whole number solutions to this. But the fact is that we are familiar with equal to, and that is how we use the the partitioning method. We are not aware of this thing. The final question type would be the grid based question. So let's start. Question will be, let's say we'll stick to the 15 only. A plus B plus C plus D is equals to 15. Guys, I'm taking you to the question type. Okay, this is just an example. Remember,
Okay.
this is just an example. You are supposed to find all the whole number solution. Okay, this is where you will start loving permutation combination. Okay, Varun, please mute yourself. And A, B, C, and D has to be greater than or equal to 1. Now, please understand what this is. This is one of the conditions that we had, now the dice condition. Hello? I'm just putting one condition. Okay, I'm just putting one condition. And don't worry too much about violation, anything. Just see, understand it logically. Don't try to mug up the, the solution schematic that I'm showing you. So I'm solving it through a logical method. Try to understand the logical method. Understand what they have said. They have said ABCD equals to 15. You need to find all the whole number solution. Okay, and there is a condition. The condition said A, B, C, and D has to be greater than or equal to 1. Now, if you have understood anything in number theory, ABCD, if 0 is not allowed, basically 15, 0, 0, 0 is not allowed. That means this question is a disguised question of asking you natural number solutions. The moment 0 is not allowed, it is only natural numbers. Okay. You will be like, but you are the one who said find whole number solutions. Then why? I said whole number solution maybe, the total number of solution maybe, but the condition is poking you towards natural number solutions. Did you understand? Hello?
Yes, yes.
How do we do this? How do we do this? How do we do this? I'll give you a very simple technique and you will be like, I'll knock it off in a jiffy. The technique is that A plus B plus C plus D is equals to 15. Na? What is not allowed? 0 is not allowed. Hello?
Yeah, so that's not allowed.
The moment, acha, give all of them 1. Substitute everything as 1.
Hmm.
The moment I substitute everything is 1. A plus, so A as 1, B as 1, C as 1, D as 1.
Hmm.
What does that mean? 0 is not allowed. Think
That's
about
right.
it. Please understand what I'm saying. Acha, I may be able to, knock it off in a jiffy right now, but now you will be able to understand this. What I'm saying is that I am substituting for A and B and C and D as 1. So I'm saying that for A, B, C, and D, if I substitute 1, 1, 1, 1, 1, each of the individual values. So I'm saying A plus 1, B plus 1, C plus 1, and D plus 1. Hello? That is equals to 50. Acha, there's a problem now, guys. Problem is that with my own whims and fancies, I have added 1, 1, 1, 1 toward the LHS. I have to rectify that. I have to correct that. So I have to add, or
Plus,
rather,
plus 4.
plus. Is it plus 4, minus 4? Think about it.
Plus 4. Because you're adding a plus 1, b plus 1 value to every number, right?
Hmm.
So a plus b plus c is 15. So a plus 1, that twice that, so 15 plus 4 would be the answer.
Mm. Maybe I am not able to explain this thing as beautifully as I should have explained. See, it's simple. It's very simple, first of all. Okay, this is not at all difficult. The fact is that how do we go from A plus B plus C? Right now, to 0 is allowed. So right now, 15, 0, 0, 0 is allowed. I don't want this thing to happen. So what I'm saying is that if I just give everybody the least value, I'll be giving all of them 1, 1, 1, 1, 1. Okay, 1, 1, 1, and 1. So let's take a 4 also to that side. Okay, let's take a 4 also to that side. Now understand, the moment I am giving A, B, C, and D as 1, 1, 1, 1, 1, I'm taking A, or maybe I'm not adding. Okay, I'm not adding 1 to both sides. I'm taking away 1, 1, 1, 1, 1 from them. Okay, A plus 1, B plus 1, C plus 1, and D plus 1. Distributing 1 to all. Now, when I distribute 1, 1, 1, 1 to all of them, there is a scarcity of, and I'll explain you why I'm doing all of that. The moment I'm taking 1, 1, 1, 1 from them, taking 1, 1 on out, 4 out, total will be 11. Okay, right now it is 11. Now understand what is in the left hand side. It is A plus B plus C plus D. And I have taken 1, 1, 1, 1 out. Okay, I have taken 1, 1, 1, 1 out from all of them. Okay, transforming the equation from this to that. I have transformed the equation, and transformation because I need natural number solutions. Okay, now at this point, this question can be solved exactly like the whole number solution. So the answer would be, it is 11 plus 3, 11 plus 3 by or C3. Okay, 11 plus 3, that is 14C3. 14C3. Had this been whole number solution, what would have been the answer? It would have been 18C3. Matlab, for A, B, C, D to be whole numbers, I would have gotten 18 3C numbers. Right now I'm only getting 14C3 numbers. And all these individual A's, B's, C's, and D's, they can be any number. Guys, please understand at this point. Hello, please understand this. It could be 0, 0, 0, and 0. But I am saying, even if A is 0, I know that I have taken 1 from A. Na? I have taken 1 from A. This is what I did. I took 1 from A. Now, if A is 0, I will again add 1 back to it, because fundamentally to A plus B plus C plus D is 15. The moment I take 1 from it, even if I solve it with using the whole numbers method, the 1 will come back and it will still add up to that value. That means A will not be 0 in the parent equation. Okay, I'll explain it again, but just look at this once. Just look at this once and ask your queries, whatever. I hate permutation combination. You know, it makes us talk so
Even
much.
I started hating.
No, I hate because it makes me talk a lot.
Getting confused actually, to be frank.
Bolo, kahan pe? At which position you get confused?
That green one, A plus 1, B plus 1,
Chalo,
C
we'll
plus
do it again. We'll do it again. See, understand this. We said the condition is, both of you pay attention, yeah? A plus B plus C plus D is equals to 15. And we have a condition somewhere over there says A, B, C, and D has to be greater than or equals to 1. This is a condition. Forget about this for a while. Now, had the condition not been there, I would have very easily solved for all the whole number solution. And actually, my dear friends, the whole number solution method is nothing but the partition method, na? The partition method, right? Whole number solution partition method. But the problem is that if I use them as whole numbers, I will violate the condition. The condition is that all of them has to be greater than or equal to 1. Greater than or equal to 1. So A could be 2, 3, 4, 5, 6 and till whatever, infinite. But it has to be minimum, it has to be 1. Minimum B also could be 1, C also could be 1, and D also could be 1. Now, I am taking 1 from A. I basically was making an error. I am taking 1 from A, from B, from C, and D. The moment I take, so say I am taking A plus 1 plus B plus 1 plus C plus 1 plus D plus 1. Okay. That is equals to 50. Not adding anything to the right hand side. That you shouldn't do. Understand what I am saying? Now this is effectively A plus B plus C plus D. Okay, that is equals to 15 minus 4, that is 11. Now, why is this process important? Because now when we have transformed the equation to this thing, we don't have to think about natural number solution method, a different method for natural number solution. Now I can just simply employ my tactics. So what if I put, let's say, now I put my method. So 11 dots and 3 sticks, and all whole number possibilities are there. So the moment, so you will get some values. Now you will get the values of a, b and c, d. You will get a, b, c, d. You say, sir, I'm saying okay, okay, sir, I'm getting a as 0, b as 0, c as 0, and d as 11. And at that point I will say, okay, hold on, a is 0, perfectly fine, perfectly fine, but I have taken 1 from a na, so I will give a 1, I will give b 1, c 1, and I'll give d also 1. Now this is 12, 13, 14, 15. So the final equation is intact. What we did a little bit of modification just to make our life easy. From whole number solutions to this is also whole number solutions. Hello, this is also whole number solutions. But this equation will give you natural number solution for the parent equation. For the
You will get
parent equation.
0 plus 1, right?
Yeah, what?
0 plus 1, right?
0 plus 1, where? Where 0 plus 1?
So 4 numbers and natural numbers.
Varun, articulate yourself. I'm not able to understand.
No, I got it.
Yeah, I 0 plus 1 is what? Where is 0? Where is 1?
No, I'm saying this whole number solution means whole number, the condition where 0 is included.
Huh.
Yeah, and adding, I'm not sure if I'm saying right, but I'm sorry if I'm making blunder. Okay.
No, see, listen, you have still not understood, maybe. Understood. What I'm saying is that if the conditions were not there, what is the value that you would have gotten? That would have been 18C3.
18C3, yeah.
Now it is 14C3. What is the difference? The difference is that the numbers has reduced, and it should reduce, na? Because whole number solution to 0 is also allowed. So there will be many iterations. There will be many permutations with 0, 0 in between. We have just eliminated those permutations in which 0, 0, zeros were there.
Okay. Understood.
Don't worry, you will take some time. It is not very difficult. It's also like you need to practice, buddy. You have to practice in order to understand. Okay. But I think this is the most elaborate way to explain this thing. Otherwise, take a screenshot, mind.
If in case of all numbers, the numbers would be large, and if case of a natural numbers, numbers would be less. That's
absolutely, because obviously natural numbers are less, na. Because you will have many more permutation with zeros in between. But now I have restricted myself that A, B, and C and D has to be greater than or equal to 1. Okay. Chalo. Chalo, I'll give you a question. You will understand. I will understand if you have understood this or not. Okay, I'm giving you a question. And I didn't want to like, acha chalo jo bhi hai. W plus X plus Y plus Z is equals to 15. Do we have one more R, guys? Guys, do we have one more R?
One more hour? Okay,
For you guys will be okay if I extend it to one more hour?
Yeah.
Varun?
Okay, sir.
Okay, chalo. Again, you need to find whole number solutions. I am making your life so much more easier by saying whole number solution. Ideally, in some textbooks, you will just find the total number of solutions. The total number of solutions. But understand, if it is total number of solution, it is hell bound to be whole numbers only. Sir, what about the negative this thing? In that case, they will specify that non-negative integral solutions. What is non-negative, guys? Anything that is not negative. So non-negative integer solution is also whole numbers, by the way. It is not natural number. If they are explicitly saying that just find the positive or integers, They could also say positive integer solutions. So either positive integers or this is as good as natural numbers. But I have taught you guys number system very details. Mein. I've taught you number system in much greater detail. So I don't think at this point non-negative integer solution and all that should, irritate you. So w plus x plus y plus z is equals to 15, and you need to find whole number solutions. But the conditions are
Oh, too many conditions.
if you solve this question now, I'll understand that you have understood my method. I'm giving you 2 minutes, 3 minutes, whatever. I feel like, listening to some songs or something. My brain has basically froze.
Yeah, mine too.
Ajay, I have something to ask you, Varun Gopal.
Yeah.
You said you had installed a SSD into your system.
Yeah.
So this is a basic. So you're saying this is a SATA SSD, na? Do you remember which brand or anything?
I don't remember. I
How much price did it took at that point?
1,500.
Oh, so that means 500 GB or something.
Yeah, 500 GB.
Okay.
Because my laptop was restarting, bugging every time, so I had to put an SSD.
Ever expanded RAM or anything?
Nothing as such.
How much is the RAM in your computer?
Actually, I don't remember. It's 8 GB, I guess. So all that.
Chalo, it's okay. You're like that typical engineer guy who has no idea about.
Yeah, I'm not a tech savvy, by the way. This laptop is meant for you. It's a 10-year laptop. And even my parents used to, oh, this dude is protecting everything he's having.
HP is a very awesome brand. I would have gone for HP. Currently, the one that I'm using is an MSI.
MSI. What's that?
What?
MSI.
Yeah, MSI.
Is that a brand? I have never heard about that.
Yeah, it is a brand. So the one that I purchased is an MSI one, and it's a decent one, not very hi-fi. The HP ones were a little expensive, so I didn't wanted to inflate my budget, and that's why I have gone a little. Basically, I bottlenecked at that price point. So yeah, I am thinking of expanding. What thinking I anyways had decided in my mind that I'll increase the RAM and all. So that's why I just was asking, and also a little bit of internal storage. So I thought instead of going to hard drives, let's invest on SSDs.
SSDs, right? Okay.
External is also fine, but since I was getting the 1 terabyte at a lower price, so I got this one. And just for information sakes, the current laptop has 512 GBs of SSD already pre-installed. So I'm expanding it to another 1 TB. So 512 plus 1 TB.
Wait, this MSD is a Taiwanese brand, right? So it has to be good. Taiwans are meant for this semiconductor thing. They just leave on semiconductors. That's it.
Yeah, MSI is a
So Thai brand.
Yeah, actually, yeah.
See, even HP, whatever it is, Taiwan is giving them the every cards and every boards.
HP is a very good brand. But it's also very expensive. Like I remember one time my internal fan, the laptop fan, got out of this thing. I went to the service center there, and my warranty obviously was over. So they were like 10,000, 12,000, 15,000. I like, go to hell. I got it off market, and yeah, it's putting up. So basically, that is one thing that I have realized, that if the warranty is out, there is no point going to the service centers.
Yeah. See, all these things are made up for the warranty. After the warranty, they will show some issues.
Yeah. Okay, chalo, answers. Varun, do we have any answers? Varun, answers?
Trying, sir. Not getting. Okay.
Acha, what is it that I said the in the previous question, that just look out for the whole number solutions with the conditions. Conditions say w has to be greater than 1. So I'll put that condition. ठीक है? I'll take one from out. Minimum I'm taking one out of that. 2 out of y.
2,
3
3,
out of
3,
4
4,
y,
4.
and 4 out of z.
4 plus 3, 7 plus 2, 9 plus 1, 10.
Is it 7?
9, 10.
Yeah.
Then 5 comes. W plus X plus Y plus Z is 5.
So now I have w plus x plus y plus z is equals to 5, right?
Yeah.
If I have this thing, now I have already taken care of the fact that the numbers are I have taken care of the conditions. Now I just need to put the n plus r minus 1 c r minus 1 formula. So that is going to be how much? 5 plus 3.
3, 3, 8 factorial by 5 factorial by 3 factorial.
Yes. So the answer will be 8c3, na?
Yeah.
We already have solved a similar question in the previous one, but still I am giving you this one, which is, let's say you have the same condition, w plus x plus y plus z, that is equals to 15, and w, x, y, and z has to be less than equals to 8. This is the question, the same question that we solved. Remember the violation thing, less than equals to 8.
So W is equal to 9.
Acha, give me a final answer then.
Okay.
Because the last question I was also not sure, because I was not paying too much attention, so maybe
Is that 8 factorial by 6 factorial by factorial 8 CD?
no. Actually, I made a error in the last question. The wxyz equal to 15, and that 10,000, the sum of the digit. What was the answer that we got? Anybody remembers the answer that we got?
11 C. 3.
No, the one in which we had um, digits less than 10,000 adding up to 15. That question.
Yeah, for the whole number that was 18 C.
Chalo hatao, let's do this one, and I'll tell you what error I basically made. As a very silly error though. That's a
Okay.
very silly error. I'll tell you what mistake I made. Again, if I didn't have the condition, the answer would have been 18C3. But I know that is not the case because I have violations. And the violations are because my upper limit is 8, right? So let's violate the condition. Substitute this as 9. The moment because it has to be less than equal to 8 and everything is perfect. Less than or equal to 8, everything perfect. The moment I substitute 9, it is in the violation territory. But now it will be substituting for w equals to 9 makes, guys, please fill my words, that is x plus y plus z equal to 15 minus 5, that is 10 minus 4, that is 6. Now this is the total number of violations that I will get when I substitute for w. Remember that. I'll tell you where the mistakes were. was, and it was a very simple, silly calculation. Not even calculation, just a, I didn't pay attention to it. Violation would be whole number solutions to this. That is going to be how much? 8C2. Is this okay, guys? Hello?
Yes, sir.
Yeah.
ठीक है? Let me think एक second. If I'm no. See, I think I made the same error. Okay. I cannot just substitute the value. I cannot just substitute the value of W. I have to take 9 out of W. That is my violation. Yeah. So this is going to be, the violation would now be something like this. Okay, please understand this. This is going to be W plus X plus Y plus Z is equals to 9, because why? Because this thing is, I'll try to write it over there. 15 minus 9. Okay, 15 minus 9. 9, because I'm taking 9 out of W. That is a violation. We are in the category of violations now. Equation still remains W plus X plus Y plus Z equals to 6, and this time it will be 9C3. Okay, this is perfectly correct. Okay, I was also getting a little confused, sorry for that, but this is perfectly correct. So the answer is going to be 18C3 minus 9C3, but everything is perfect. There was one mistake. This is one of the possible cases when I have taken 9 from W. I can similarly take 9 from X. I can similarly take 9 from Y and Z. So that means this 9C3 will be 4 times. Okay. For each individual variable, I can take this out. Basically, this 9 that I have taken out can be given to any one of the 4 among X, Y, Z, W, right? And this is the final answer. This is absolutely correct. And this is the final answer that you will be getting. Look at this thing and ask any question if you have. At this point, you may be thinking that, will I ever be able to solve these kind of questions? Definitely. If you solve some question material from the handouts and stuff, you will be able to solve these questions. Guys, responses.
Yeah. 1860. Yes. That is without violation. Understood.
Varun,
Sir.
Samundram.
Yes.
What about this?
I am okay, sir, but I need to again go through it once.
Yeah. You will have to. You should, because at least take the screenshots and try these things out.
Yes,
You
sir.
have the Unacademy PDF. Try the questions from there also.
Yes, I will, sir.
But don't get overboard, because
Okay.
these are the all different type of questions that you can be asked. Chalo, एक question और करते हैं. You guys will do it. Question is, find the number of integer solutions, or find the number of integral solutions for a plus b plus c equals to 30. You will be, oh, chalo, 30 equal to sign. I'm very happy. Where ABC is greater than equal to -1. Greater than equal to -1. Find the number of integral solutions. Integral solution. Okay. Integral solutions. Guys, at least tell me, is it doable, not doable?
This ABC is greater than -1, so I put -2 to consider the violation.
-2.
Now, ABC has to be greater than -1, right?
Violations come when there is a upper limit. There is no upper limit here. Okay.
Okay.
Violations comes when there is a upper limit less than equal to something. Here there is no violations. Here there is no conditions as such. So I've given you enough hint. I'm going to be silent. I'm going to take a 2 minutes break. Yeah, I'll be back. Yeah, I am back. I am extremely sorry I'm keeping you guys. But these questions and it's basically frying my brain. You have to say so much, and then I also have to keep things in mind that I cannot push too much. Otherwise, you guys will go nuts. Chalo, do you have answer? Guys, there?
Yes, sir.
Varun Gopal is there?
Yes.
Answers, answers, answers. Acha, let's start with Varun then. Varun, any answer?
No, sir.
Arey Baba, why no answer? They're
I
just
don't.
asking for
Okay.
greater than or equals to
Close to
1.
one.
So let's start with -1. Yeah.
Minus. Minus.
If they say that there is a condition for ABC greater than equals to -1, that the number has to be greater than or equal to -1. That much I know, right? They're
Yes.
asking for integer solutions. Find integer. Okay, I should have written this thing also, but okay, I have said this. Find the number of integer solutions, right? So you should at least start doing something, na? Like for example, a plus b plus c is equals to 30. And since they say abc has to be greater than equals to -1, I'm just saying ki at least take away -1 from all of them. Because for whatever integer solution, non-negative integer solution, natural number solution, I don't know anything. I only know for whole number solution. So convert it into a whole number solution system. So this is going to be, I've taken -1, -1, -1. Basically, I'm taken -3. So I will send the 3 to that side. Okay. So now please understand, this could be a little, you know, if you're not paying attention, this is a +1, and +1, right? So suddenly don't do 30 minus or 30 minus 3 only. It is a negative, negative, negative you're doing. So ultimately you're getting how much? 33.
Yes. I did 27 here.
So a plus b plus c will be 33. How many whole number solutions you'll get? 35C2. And yes, this is the answer. As simple as that.
Okay, sir.
But sir, you said that 0, 0, 0. That is for upper limit. This is not upper limit. This is I didn't wanted to use the word lower limit, but ठीक है. What is an upper limit? Upper limit is that ceiling. You cannot cross the ceiling. But we will cross the ceilings for violations. Remember that. ठीक है?
Okay, sir.
There is a special case which I'm not going to teach you because even I am, let's say, how shall I put this? Chalo, I'll see. Chalo, I'll see if I will be able to make sense. So the question is, w plus x plus y plus z is equals to 15, and now the condition is w, x, y, and z has to be less than or equal to. Understand, this is a upper limit question. Half of 15. This is a highly error prone question. This is one of those PNC questions which if you start solving, you'll get many answers, many violations, and basically multiple overlaps. So when we solve this thing, we have to particularly pay attention to the numbers which are less than the half of 15. Half of 15 is 7.5. So could be something like 6, 5, and anything. Even 7 will also work. Okay. So these are the type of question that is error prone, right? Could be 5 also, 6 also, 4 also, 7 also, and you understand, right? The the fact is that I probably will take a session on them some other time. Okay, once the cat is over, maybe, because I'll also will be thinking on them. Chalo, let me give you a difficult question. Okay, let me give you a difficult question. Understand the question, I will solve it. Okay, just understand the question and I will solve it. Take a screenshot of this and keep this in memory. Leave this type of question. I'm telling you these questions because you should also be aware that what type of questions you should be leaving. Done? Screenshot done?
Yes, sir.
Chalo. Question. W plus X plus Y plus Z is equals to 15, and I'm giving you multiple upper limits now. The upper limits, remember, now violation will come. W less than 8, X less than 9, Y is less than 10, and Z should be less than 8.
Sir, here there's only one need to me. There is only one case, right? Just take W is equal to 9, and that would be the rest of the violation would be counted, isn't it?
No, that is what I was thinking to tell you, but it's a good thing that you asked me. The violation for W is not same as the violation for Y. See that, because Y till 10 is allowed, W till 8 is allowed. So if you just take one case and think that is equal for M, that wouldn't satisfy. So there is a easy, although it is hard.
Wait. Okay. Is that like Y will take 11 and they will count X Y W plus X plus Z is equal to 4.
Acha, without this condition, the answer would have been 18C3
Hmm.
minus the violations. Now, do you remember when I had just one violation, I was multiplying it by 4. So if you have
Yeah.
understood what I am trying to tell you, it will be violation for W into violation for X into the violation of Y into violation of Z.
Hmm.
Okay. So this time around, it is not going to be multiplied by 4. This is going to be 18C3 minus something into something into something into something. It's a easy one now. Try this out. I know you guys will be a little bit exhausted also. Look at this for 30 seconds. Let me solve it. Soumya would not have listened to this logic. She would say, no, I'll solve because, in the exam, I need to solve. And then probably she'll take 5 minutes, 10 minutes. But that's a good habit.
If this was an arithmetic session or geometry session, I would have asked.
Huh? You would have?
If that was an arithmetic session or a geometry session, we would have said, "Sir, wait, let us try it."
Yeah, that is the thing. You guys are like I didn't want it to be that kind of a teacher who would not teach PNC.
Yeah,
I didn't want it to be that, because
but again, if
if I,
from a
how, what type of a teacher would I be if I preach you should not be leaving any topics, and then I myself am not teaching you permutation, combination, as well as probability. So as a faculty I should be teaching, but I understand what you are saying. I as a when I was also studying, but then the thing is that you are under the guidance of personal coaching, so to say. So make use of that. Had I been doing everything on my own, I would have also left it. Chalo, let's solve it. Okay. How do we uh, uh, how do we solve it? We will make use of the violation for W. Okay. So I'm just gonna write it. All we need to do is we need to add +1 for individual variables for individual violation. Okay. So if you have understood what I am trying to say, for W, this is going to be 9, right? Now, if this is 9, 15 minus 9,
15 minus 96.
Salah, this is the problem. This is the problem. It is not going to be 6 or whatever. For W, if I'm just paying attention to W right now. Okay. Forget about the violation for the others. If I just, just understand one thing. W has to be less than equals to 8, right? I hope that is clear. W has to be less than equals to 8. So obviously I will violate W by adding 1, violate X by adding 1, and so on and so forth. For W specifically, I should be getting how much? Just think about it. Go back to what I was teaching you. Acha, the moment I substitute W is equals to 9, whole number solution is available.
Yeah,
I'm still not able to comprehend. I'm still not able to comprehend. So if I just give it 9, so this has to be 9C3. Na? You see, even I am getting a little confused. This is a difficult. I told you, na, a hard question. This in fact is a hard question. Just give me 1 minute to think on it. Yeah. देखो, if I substitute, you said 6, Varun, you said 6, right? If I substitute W, I mean not substitute, I have this bad habit. If I take away 9 from W, what will it become? It will be W plus X plus Y plus Z equal to 6, na? Hello?
yeah,
And how many possibilities will there be with the violation now? How many possibilities of whole number solution? 4 variables, and over there you have 6.3 lines. Can I please say this as 9C3? This is very easy for me to write. Is it okay if I write it 9C3?
yeah.
Now I will not multiply by 4 because every other variable is different. So this is individually for W. Let's calculate for X. That would be 10, na?
Hmm.
So W plus X plus Y plus Z will be how much, Varun? Quickly tell me.
10, 15, my 5, 6.
Are you sure it is going to be
Nine,
uh
should we add 9 plus again
is it
9 here?
I want the final number. Is it 8C3 or not? Just tell me that.
Sorry,
Whole
sorry.
number solutions. What did you break?
I maybe anything. My mouse. I don't know. My phone.
Varun, are you able to understand this or not? You will be able to understand it once I'm done. Okay. So this is 8C3 for Y. If I violate it individually, this will be 11. 15 minus 11 is how much? 4, na? And again, W plus X plus Y plus Z, total number of solutions, total number of whole number solutions. 4 plus 3, 7C3, correct? For Z equals to 9. Z equals to 9 is very easy. We have done this thing. So W plus X plus Y plus Z is equals to again 9C3 because 15 minus 9, 8. Sorry, 6 and then 3. So 9C3, right? So these are all the individual violations.
Okay.
Varun, Gopal and Varun Simam Samudram, please confirm to me once if thus far it is you are able to understand what I am saying. We are
Yes,
looking at
understood.
individual violations now.
Yes, sir.
I know this is a little twisted, maybe. So now you have the answer. What is the final answer? So this is going to be 18C3 minus 9C3. Are you going to add them? No, they're individual violations. So remember the rule of and. So this is 9C3 into 8C3 into 7C3 into 9C3. This is where things becomes a little difficult. This is your final answer. Okay.
Okay.
If you want, I can explain it again.
Actually, I understood this, to be honest. I understand. Seriously, I'm saying understood this.
Take a screenshot. Take a screenshot. Try
Yeah.
this out. Okay. Take a screenshot. Try this out.
My screenshot button doesn't work all the time. Right.
Why don't you use the snipping tool?
Yeah, wow.
Yes. Use the snipping tool. That's it.
Sir, actually, it's 12:30, sir.
Ah.
To be honest,
Who said 1 hour? Who said 1 hour?
exhausted.
You just now you said you were understanding everything. I
Yeah,
thought
I
we'll like
understood this. I
I
understood
thought
this.
I thought we'll complete probability tonight.
Probably.
No, I really thought that we'll yeah. Let's finish probability, yeah. Yeah. Chalo, one or two more questions and then we'll be done.
Yeah.
Yeah? One or two more questions and we'll be done. Now we'll do quickly. A similar question to what we have solved. Please pay attention. You can solve it, or if you cannot solve it, just tell me. I will solve it with. I will try to solve it with you guys. Also, please pay attention to the difference in this question now. How many numbers less than 100,000 this time will add up to 16? First of all, 100,000, how many digits are there?
5,
No?
6, sir.
6.
Yes. So less than that will have how many digits?
5 digits.
So this is going to be A, B, C, D, E. Will have to add up to 16. But the condition, there is a condition. Obviously, A, B, C, D, and E will have to be less than equals to 9. Remember?
Hmm.
Had the condition not been there, my answer would have been very simple. It would have been 16 plus,
16 plus 4,
that is 20
20.
C4.
So 20 C4.
Yeah. But I have violations.
Greater less than or equal to 9, right?
Everything
So
less than equals to 9.
A equal to 10, B plus C
Yeah.
plus.
The moment you substitute, now just see what I'm doing. The moment you take 10 out of A, this will be A plus B plus C plus D is equals to 6. Right? Hello?
Yeah. So 9 C3.
No. There are total 5 letters. I'm extremely sorry. A plus B plus C plus D. 5 letters,
Oh,
right?
5.
Yeah.
Okay.
So this is going to be 6 plus 4, that is n plus r minus 1. Na? So
Hmm.
10C4.
10
The
C4.
and I had just taken one violation ka case. There will be total 4 such violations. So the final answer
20 C4 minus 10, 4 and 10 C4.
20C4 minus 10C4 into 4. Okay.
Yes.
This is your answer. Take a screenshot of this one. Oh, I'm extremely sorry. 10C4 into 5. Why am I
5.
constantly doing 4? 5. Remember 5.
Yeah, because we've been doing with
Yes.
4 for a lot of
Yes,
time.
yes,
That's
yes,
why
yes. That also has given me.
that cognitive bias comes.
And that is okay. That is
Yeah.
completely okay. But at the end, you just check your answer. Is it making sense or not?
Mm.
Done? Screenshot?
Yeah.
Chalo. Next question. Just 2 more questions. I know that you guys will never watch the recording. So at least the screenshots will help you to revise certain things. So maybe all the screenshots that you take now, just make a PowerPoint presentation and add all the screenshots there and try them out whenever you have time. Okay, one interesting question coming your way. And that's it. Basically, you need to find how many whole number solutions. This is now, if you understand, this is I am trying to revise you. So what is it that we understood earlier, that we know something about the equality, not inequality. So we will have to transform first of all. Oh, this is the only one that I have not taught you, no?
Yeah.
Arey yaar. Okay.
We'll tease tomorrow.
No. Listen. So x plus y plus z less than hold on, less than equals to 9. Okay. We
Yeah.
need to find the total number of whole number solution, the total number of whole number solution. But we have no idea how to solve inequality. We have some idea on how to solve equations. I am giving you a let's say algorithm, and that algorithm is as simple as that. Just add one more variable. The moment you add the variable, this becomes a equal to. Okay. Transformation of the logic I will give you in a different class, because I need couple of questions to solve to give you the logic. Inequality, transforming the inequality to equality. Just add one more variable. Anything. I have used an alpha. You can use anything. You can call it a D also. Now tell me the answer quickly.
13. 9 plus 3, 12. 12 C3.
9 plus 3 is
12
Yeah. There is
CP.
you said 13 and all.
12 CP.
Take a screenshot.
Yeah. Done.
Okay, last question type, the grid-based question. Okay, the grid-based question. Mm. Okay. Before the grid, I'm leaving this question, which is uh, mod of x plus mod of y plus mod of z is equals to 10. Okay. Find the number of integer solutions to this equation. This is an extremely difficult question. It will have three cases if you understand, because obviously three mods, na? Positive, negative, as well as 0, 0, positive, 0, positive, negative, 0, positive, negative, 0, positive, negative. Total three cases will be formed. And the final, try to solve this. Use as much resources as you can. I'm giving you the answer. The answer to this is, the final answer to this is, yeah, take a screenshot. This is the final answer. Done?
1 minute.
Yeah.
Done, sir.
Number of integer solutions.
Done, sir.
Yeah. Find the number of integer solutions. And this is the final answer. Maybe take the screenshot of this one. Or maybe I'll just get rid of this one. Hold on. Take the screenshot of this one. Done?
So,
Done, na?
yeah.
Yes, sir.
This is an excruciatingly difficult question because you can yourself see this is the answer that you will get from the first case, second case, third case. The three individual cases has taken me north of 10 minutes. I'm not saying 10 minutes is too less or too much. What I'm saying is that you have to constantly look out if there is any error. So like it takes a lot of time. Okay. Chalo, the last question and then we'll then we'll be done with this session. The grid based question. And this is something that has been asked in the CAT. So, pay attention. This has been asked in previous year CATs. So it's very simple actually. It's very simple. There is a grid like this. Okay. And A, B. Okay. There is a person. Question is, I'm okay, I'll write it. In how many ways uh, can he go from A to B, provided condition, provided in how many ways can he go from A to B, provided condition he can only travel horizontally rightwards Okay, this is the condition: horizontally rightwards and vertically upwards. We will meet probably Tuesday next week, so that's why I am hell bent on completing this theory. Now, just understand this. I'll give you the theory, and the theory is, matlab, it's so simple. You'll understand it in 2 seconds. So just look at this thing. There is a person, at A position. From A position to B position, he has to go. Okay, how many ways he can go from A to B, provided that he only travel horizontally rightwards? That means, what does that means? Horizontally rightwards and vertically upwards. That means that I can go from this to this, then I can go from here, then I can go from here to there, and this thing is allowed, this thing is allowed, allowed. What is not allowed? Going from this to this, then here, and then coming back. So leftward is not allowed. Only rightward on this thing. Okay. How many such possibilities are there? Actually, you can sit and count. I would really appreciate if you guys can sit and count. But there is a quick fix. The quick fix is that because it's a rectangular mesh, and we know that we are only operating between horizontal and vertical iterations. So just count how many horizontal iterations are there. 1, 2, and 3. Vertical iteration: 1, 2,
2,
3,
3,
and 4.
4.
Now, basically, my dear friends, all there is for you to understand is that H, H, and H, and V, 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 and V. So there are 3 H's and 4 V's, and we just need to find as many permutations as we can. Hello, do I know how to find the permutation of H's and V's in this case? How many
Yes.
arrangements can you make out of H's and V's together?
6
Tell me quickly.
factorial, 6 factorial by 3 factorial.
Not 6 factorial.
4 plus 3 is 7.
This is 4. This is 3. It's 7.
7 factorial by 3 factorial 4 factorial.
By 3 factorial into
4
4
factorial.
factorial. There is a formula also to this thing, and that formula is as silly as this. Okay, I'll write the formula. So the formula says H plus V factorial by H factorial into V factorial. Okay, as many horizontal steps plus vertical steps by this. This is a formula. Take a screenshot. Hold on. Take a screenshot of this one. Done?
Yeah.
Yes, sir.
Okay, now I'll give you one question and then you can go. One question and then it's over.
So homework?
No. You'll solve it. Homework. Are you in
Yes.
10 standard? Homework. What is homework? There could be actually many iterations that one can make. So for example, I can possibly say that, I'll teach you those things that, this position is not available. Let's say that this position is not, doesn't really changes much about this question. It's just iterations and stuff. Okay. So yeah. So from A to B, the happy boy needs to travel. How many ways can be for him to go from A to B? And actually, hold on. Yeah. Let's make this a little complicated. Little, not very much, little. I'll add additional complexities some other time, but yeah. How many ways the boy can go from A to B via C? And now you see, this is as silly as the question itself. In how many ways can he go from A to B via C? And obviously, the only allowed, let's say, the positions are rightwards horizontally and upwards vertically. Immediately, you will realize that the only possibility will be this one, this one, then this one, this one, this one, this one, this one.
Right.
Could be something like that, or maybe go this way, this way, this way, this way,
Yeah.
then this way, and maybe this way, this way, this way, this way, this way, and this way.
So you are
Or
saying separate calculation, right? Adding.
no, 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 no. You can use some ideas. Understand the question is he can go from
Let me
A
ask,
to
ask you something.
yeah. Please go ahead.
That first of all, we'll take from the first point, like that first dot. It is having one, two, three, three vertical and two horizontal.
Acha, dekho. I will give you the key to this question. The key is that the question is he need to go from A to B via C. So he will go, or he can go rather, he can go to C from A. Okay. And then to B from C. Now please pay attention. Is this information helping you? So if you have understand now please consider these as two separate questions. One like this and other like this,
And
and
adding
both
that.
of them are joined by this and. So like I am your teacher, so I am giving you the solution, but then ideally this is something that you should have done in your spare time, or maybe when you practice other question, try to look out for these type of hints. And I'm
Okay.
telling you, this is nothing more than this. Okay, now tell
That
me the
is
answer.
for the first circle, three vertical, two horizontal. Okay.
Yeah,
So yeah, five factorial by two factorial into three factorial.
final answer you're giving now.
Yeah, first for the first circle to reach the first point.
A to C.
A to C, five factorial by two factorial to three factorial.
and
Plus
and
into. One, two,
do we
three,
say
four.
do we say we go from A to we can go to C from A, or we can go from B to C, or is there a or element or an and element? You have to go to B na via
Yes.
C. So and
And,
remember and
okay. And okay.
yeah,
And for six factorial by four factorial,
6.
two factorial.
Absolutely perfect. This is the answer. But you can calculate this also. The value will be 50 ways.
Okay.
And this basically is it. The entire theory, barring grouping, is over. There is a little bit of grouping also left. So that we will do in the next 1 hour, and then we'll complete probability, right?
Okay. Yeah, I'm gonna sleep. Okay. I'm gonna sleep.
Achha, at this point, you guys must be thinking that where are those permutation combination question that, how many signal consist of at least one flag and,
Nothing
5
is
flag.
wrong inside.
Yeah. So it's a very deep chapter, permutation combination,
Yeah.
but then yeah. I hope that the grid method is not difficult. I
It's
hope you
very
have
easy.
understood.
Yeah.
You can just practice your PNC questions also now. Okay, previous year questions will not now prove to be very difficult. Uh, if I can pull out some time, maybe in the afternoon tomorrow, we will complete grouping and PNC will be over.
Yeah.
If you guys give me 30 more minutes, I can complete grouping.
Sorry,
But
sir. I'm really sorry. I didn't say to you, but I'm really sorry.
like 45 more minutes and grouping will be over.
I'm going better. I will watch the recording.
The problem is that if you watch the recording, you'll not understand anything.
Yeah.
Anyways, chalo, bye.
Good night.
Yeah,
Okay, sir. Bye. Good
yeah.
night.
Good night.